Welcome to Secret Squared. I'm Cassie Secret. I'm Megan Secret, and today we're going to talk about how to solve radical equations. So let's dive in. Okay, so for our first example, when we're solving a radical equation, there's different radicals that you could see. One of the most common ones by far is definitely seeing a square root. So for us to handle this equation, the first thing that we want to do is we want to isolate the radical or get it on its own. Now, again, that could vary on the problem. Sometimes it could be a square root. We will see one later that's a cubed root. So we want to get that square root all on its own. So to do that, let's get rid of that plus 3. I'm going to subtract 3 to both sides. So now I have square root of 2x minus 4 equals negative 3. And now that I have that square root on its own, the goal is to get rid of the square root. And the thing that reverses the square root is actually squaring something. Those two are inverse operations. So my second step is we are going to, now in this case, we would say, well, to undo a square root, you would square it. But if it was something different, like let's say if it was a cube root, then you would cube it. So the more general way that we can explain this step is we're going to raise both sides of the equation to the index. Now, that index is whatever number's here. Now, in this case, for a square root, there's an invisible 2. But if it was a cube root, then you'd use 3. If it was a fifth root, you'd use 5, or whatever it may be. So we're going to raise both sides to the power of 2, or square it. So from there, I have 2x minus 4. The square root's now gone. The other side, I get 9. So now I have an equation that I can really easily just go ahead and do my next step, which is just solve it. If I solve that, I'm going to go ahead and add 4 to both sides. So I have 2x equals 13. And then keep going, divide both sides by 2. And I'm going to get that x is 13 over 2. Now, where you want to be careful is sometimes when you have a radical equation, you might have what's called an extraneous solution, or a solution that is actually not going to end up working. So our fourth step here is we actually need to take our solution and we need to check for extraneous solutions. Now, part of the reason that extraneous solutions show up is because of that square root. And I'll show you us checking it, and then I'm going to show you something back in the equation. So let me go ahead, and I always like to label where I check it to make my work nice and clean. So if I check it, I'm going to take my answer, or my solution, I'm going to plug it back in and make sure that it works. So if I take our equation, I have 2, and then times our answer we got was 13 over 2. Minus 4 plus 3 equals 0. And we want to see if this is going to work. Now, 2 times 13 over 2, that's just 13. So I have square root of 13 minus 4. And then I have plus 3 equals 0. If I keep going, then I have that square root of 13 minus 4, which that would get me square root of 9. Make sure I don't run out of space. So that would be square root of 9 plus 3 and equals 0. And if you were to keep going with that, you would actually get square root of 9 is just 3. But that would be, on the left side, that would get you 3 plus 3. So that would be 6 equals 0. And that's not true. So actually, this one was an extraneous solution. So we are going to reject our solution. And your answer would just be no solution. That's it. And actually, part of the reason why that happens here, if you go back in the work, there's one point right here where we have the square root of something is going to equal a negative number. If you square root something, you're never going to get a negative, and that's actually part of the reason why we end up having no solution here. Okay, and then for our next problem, same type of idea where we have the square roots. It just looks a little bit different because we have now 2 square roots instead of just 1. So it looks a little bit different. Our first step is still going to stay the same, where our first step was to isolate the radical. If you have 2 radicals, though, they're already isolated. Each radical gets its own side. So now we'll jump to the next step, where you're going to use the index. In this case, there's that invisible 2 as the index. And you're going to make that the power for both sides. So we have the square roots. So we're going to square both sides. And as Cassie said earlier, it's because it's the inverse operation for the square roots. So now on the left side and also the right side, we don't have any more square roots. So we're going to end up with now 2x plus 1. And again, this only happened because the index was 2 and then the power was 2. They cancel each other out. And on the right side, we're now going to have the 10 minus the x. At this point, we don't have any more radicals. It now turns into a normal equation that you can solve. So you could solve this a few different ways. Let's say you want to move the x on over. So we have a 3x, and then we solve everything else. We can move the 1. And now we have 3x equals 9. So x is going to end up giving us a 3. So in this case, no fraction. It's a normal whole number. We have 3. Normally, if this was the equation that you were given at the very beginning, you would stop there. But because it was a radical equation, you have to check for the extraneous solutions. So off to the side, let's double check and let's see if 3 actually does work as a solution. So we're going to take exactly what we started with, but not with the square roots. So exactly this, sorry, without the square, no squaring, and we're going to plug that 3 into it. So we need to see, is it true that the square root of 2, instead of doing 2x, now we'll say 2 times 3 because we think x is 3. So say 2 times 3 plus the 1. Is that the same thing as instead of 10 minus x, we're going to put 10 minus 3. On the left one, 2 times 3 gives you 6. Add 1, we have the square root of 7. On the right side, we also have the square root of 7. Square root of 7 does equal square root of 7, so we are good to go. X does actually end up equaling 3. So we don't have no solutions. This completely works. Exactly. And it really just depends. Sometimes you're going to have a solution. Sometimes it might be like the first problem where you don't. Now, the last example that we wanted to show was one where we don't have a square root. Instead, we have a cube root. It was really going to be very similar to our first problem. First, I'm going to start by finding wherever that radical is. I know I want to get it on its own. So we're going to get rid of that -2 in front. Now be careful, that -2 is being multiplied with the cube root. So to undo that multiplication, we're going to divide it by -2 to both sides. So I have the cube root of 4 minus x equals +2. And now that that radical's on its own, we are going to raise it to the power of the index, which is really a fancy way of saying if it's a cube root, you raise it to the power 3. If it was a fourth root, you'd raise it to the power 4, and so on and so forth. So in this case, I'm going to raise it to the power of 3 for both sides. And like Megan was saying earlier, that cube root and the actual cube are going to undo each other or cancel each other out. So now I just have my 4 minus x, no more radical, and then 2 to the power of 3 is 8. From there, you're going to get some sort of linear equation that you can solve fairly easily. So let's go ahead. I want to make my x positive, so I'm going to add it to the other side. So I have 4 equals 8 plus x. And then finish it up. Let's subtract 8 from both sides. So I have -4 equals x. So I think that I have a solution that might work, but always be careful. You have to make sure that you check it. And again, I do like to label it. The cleaner that your work is, the easier it is for your teacher to follow. And so let's go ahead and take our original equation before you changed it whatsoever. So I have -2 in front, cube root of 4 minus, and in this case, my x is -4. So I have -4, and that all equals -4, or it should. So checking it from here, on the inside, 4 minus -4 is +8. So cube root of +8, and leave everything else the same. So checking it from there, I still have my -2. The cube root of 8, that's just 2, and then equals -4. So if I multiply the left side, that's -4, and yep, that does equal -4. So that means that we get to keep our solution and we are good to go. Thanks for watching. If you enjoyed this video, please like and subscribe. If you have any other topics you want us to cover in later videos, leave us a comment below. We'll see you next time.